After studying the laws of indices, now we are going to take the special cases. First is the multiple bases to same power. Suppose I have xy raised to the power of n. So here we have two bases xy raised to the power of n. Okay. So whenever we have two bases having the same power or index, then this is equal to x to the power of n into y to the power of n. So when an index is on two or more bases, then the same index is raised to the all the bases. Okay. Similarly, if I have x upon y whole to the power of n, then this can be written as x to the power of n upon y to the power of n. Okay. If we have more than one basis, a, b, c, we have three bases raised to the power of n, and this can be written as a to the power of n, b to the power of n, c to the power of n. Or in any case, we have p, q upon c, d whole to the power of 3. And this is going to become p cube into q cube upon c to the power of 3 into d to the power of 3. Okay. So that's how the multiple bases to the same power is tackled. Okay. We can also see the verification of this result. Suppose I have xy to the power of 3. Okay, xy to the power of 3 means xy into xy into xy 3 times. Okay, now because I have 3x multiplying, so x when multiplied 3 times, so I can write this as x cube. Y is multiplying 3 times, I can write this as y cube. So this will be equal to x cube into y cube. Okay, fine. So xy whole cube is equal to x cube y cube. So this implies that this law xy whole to the power of n, or this law or this case is valid for all the similar values. Okay. The next special case is the case of the negative power. Okay. Now suppose that we have x to the power of minus n. Then this can be written, so this can be written as 1 upon x to the power of n. So what does it mean? That if we have x raised to a negative value, then this is equal to 1 upon the same value with the positive index. Okay, for example, if I have x to the power of suppose minus 10, then this can be written as 1 upon x to the power of 10. Same value with positive index in the reciprocal. Okay, this value is quite used. X to the power of minus 1 is equal to 1 upon x. So generally this value is widely used in the senior classes. We use these values directly. Okay, so whenever and wherever it is required. Okay, now we can see its verification. Okay, so for verification, what I do here, I take x square upon x cube. So this can be written as x into x upon x into x into x. This x cancels out, x cancel out, so this will be equal to 1 upon x. Again, x square upon x cube is equal to x to the power of 2 minus 3, or x to the power of minus 1. So this implies that 1 upon x is equal to x to the power of minus 1. So this result is valid for x to the power of minus 1. So this can be checked for any other number. So this would be true for all negative index. So hence x to the power of minus n can be safely taken as equal to 1 upon x to the power of n. Now one more important and interesting result is this, that I have x upon y to the power of minus n. Okay, then This is equal to y upon x whole to the power of n. So here I make the negative index as positive, and x upon y can be made reciprocal and written as y upon x. Okay, so for example, if I have 3 upon 4 to the power of minus 2, then this can be written as 4 upon 3 to the power of 2. Here I made the negative index as positive and I have reciprocal the term. Okay, so these were the first two cases. In next video I'm going to talk about the next cases. Okay, thank you.